Yeah, everyone. Today we are going to start a very interesting topic. So I have a friend called Sam who is of your age only. Okay, so there is a friend called Sam. He likes pizza very much. Do you all like pizza? Yes, I can see many hands up. Yeah. Your mouth started watering seeing the pizza? Yes. Now don't get confused that this is a math class and my teacher is talking about pizza. Today we are going to relate maths to the food that we eat daily, mostly in our daily life. As I keep telling you every day, maths is related to our daily life. And if you relate maths to daily life, it's going to be super fun and super easy. Yeah. Coming back to the question, here we have friend Sam. He likes the pizza very much, so he's already a pizza of. Okay, now you have different pizzas, right? Mini pizza, big pizza. So he's ordering a pizza which has 8 slices. Now, he is eating out of 8 slices. He's going to eat only 5 slices. Okay, and then his stomach is full. So he ate 5 slices. Now, I want to represent this mathematically. Like out of 8 slices, he ate 5. So how many slices did he eat? How will you represent this mathematically? How much pizza did he eat? Can anyone tell me? How do you write this mathematically? Yes, there were total 8 slices. And if the pizza is divided equally in 8 slices, right? Yes, the word equally is important over here. We can consider the pizza as a circle, and that circle is divided in 8 equal parts. Out of that 8 equal parts, he is going to eat 5. So how many are remaining after that? Only 3. Yes. So he is eating 5 out of 8. So how do you represent it? 5 by 8. Perfect. So what is this 5 by 8, students? Yes, it's a fraction. Okay. Out of 8 pieces, he is eating 5. So we write it as 5 upon 8. And this number is a fraction. Perfect. So can you guess what is our today's topic? Yes, our today's topic is fraction. So now let's see what is a fraction. A fraction is a part of a whole. Here you can see there is a circle which is divided equally in 8 parts. It, here, two things to note. That should not be always a circle, any part. Okay, it can be any part, any particular object. It can be a circle, it can be a square, it can be a rectangle, anything particularly divided into equal parts. Okay, then we are selecting a particular part from that, and that makes a fraction. Like in the previous case of a pizza, the pizza had 8 slices, and the slices are equal, right? So the pizza is divided in 8 parts. Out of them, we are eating 5. So it's 5 by 8. So this number 5 by 8 is a fraction. 5 pieces you have selected, and there were total 8 pieces. So 5 upon 8. So this 5 upon 8 is a fraction. So I repeat, a fraction is a part of a whole. Okay, now this fraction has two things. One is numerator, another is the denominator, like a rational number. Numerator and denominator. Now, numerator will be the number of parts selected. Like in the previous example, we saw that the boy is eating 5 slices. Okay, so out of 8, how many he is eating? 5. Perfect. So the numerator is 5, the number of parts selected. Okay, then now can you guess what is the denominator? Yes, the total number of pieces that the pizza was. It is 8, right? Any object, the total number of parts will be your denominator. For example, here in the circle is divided in 8 parts. So the denominator is 8. And if you select 5 parts, numerator is 5. So I repeat, numerator means number of parts selected, and denominator means total number of parts. Okay, the circle is divided in 8 parts, so the denominator will be 8. We are selecting 5 parts. So the numerator will be 5. The fraction will be a 5 by 8. So the parts that we are selecting is numerator and total number of parts will be your denominator. This is what fraction is. Great. Now let's see how to represent a given figure into a fraction. Are you all ready? Yes. So now here you can see a circle. Can you tell me how will you like to convert this into a fraction? Here you have an image where you can see a circle. It's divided in equal parts and some parts are shaded. Shaded means the selected part. Okay. So can you write a fraction for this? Please think and then let me know. Yes. First we'll count the total number of parts circle is divided in. Let's count 1, 2, 3, 4, 5, 6, 7, 8. So your denominator will be 8. And how many parts are shaded? 1, 2, and 3. Perfect. So the fraction is 3 by 8. That is, out of 8 parts, we are selecting 3 parts. And main thing, the circle is divided in equal parts. Okay, for fraction, that is very much important. Particular object figure, we are dividing in equal parts. And out of that, whichever number of parts we are selecting, that represents a fraction, a part of a whole. Okay, very good. So now, till now, what have we studied? What is a fraction? How to write a fraction? Now we'll see how to compare two fractions. So here you can see two different figures. First circle, let's see how we, in the first circle is divided into 1, 2, 3, 4, and 5 parts. So your denominator should be 5. Perfect. And how many parts are shaded or selected? 2 parts. Yes. So what is the fraction? 2 by 5. Now with the second figure, 1, 2, 3, 4, 5. Yes. Here again the picture, the circle is divided in 5 parts. And here how many parts are selected? 3 parts. Perfect. So now, how will you compare these two fractions? If you see it just representation, don't see the numbers, that is 2 by 5 and 3 by 5. The pink one or the yellow one? Which one is more? Yes, the yellow one is more. So numerically, how will you compare? Let's understand that. First, we'll see the denominator. Whenever you are comparing a fraction, you have to check whether the denominator is same or not. Okay. What does the denominator same mean? That is, both the figures are divided in equal number of parts. The total number of parts of the first and the second circles are same. That is, both circles are divided in 5 parts. Okay. So when both the circles are divided in same parts, it's easy to compare both the fractions. So total number of parts of circle 1 are 5. Also, total number of parts of circle 2 are 5. Okay. So once you know that the denominators are same, we will check the numerator. Okay. So in the first one, that is a pink shaded part, there are 2 parts selected. Okay. And in the third, in the second figure, there are 3 parts selected. So 2 parts selected and 3 parts selected. Which number is more? 2 or 3? 3 is the bigger number. Means there are two same circles and the circles are divided in equal number of parts. Both are divided in same. That is the reason you have the same denominators. So once you know the denominators are same, we are going to go to the numerator. So once you check the numerator, 2 and 3, which one is more? 3. So that fraction 3 by 5 will be more than your fraction 2 by 5. Easy? Yes. Let's repeat once again. To compare a fraction with same denom. First thing is check the denominators. If the denominators are same, our work is very easy. We will just compare the numerator value. And fraction with the higher numerator, greater numerator is great. And the fraction with smaller numerator is smaller. Okay, so this was easy. But the next part comes here. Now tell me, how will you compare a fraction with different denominator? Suppose 2 by 5 is my first fraction and 2 by 6 is my second fraction. I can give you an example. Like one friend is ordering a mini pizza, and the other friend is ordering big pizza, which is large pizza. And the friend who is ordering mini pizza is eating three pieces, and the person who is ordering a large pizza is eating only two pieces. So who ate more? Okay, so this is a condition where you get different denominators when the circles are not divided in equal number of. Okay, so your denominators are different. So now tell me how will you compare in this case? Because your denominators are not same, so we cannot compare them directly. So let's see what to do in such cases. Okay, so now I'll show you a stimulation over here. You can observe, you can see that the fraction has an equal denominator, and if the denominator is same, it's easy to compare. Okay, that's what we have seen in the previous one. Now I will change the denominator. Okay, so the one denominator is 13 and the next denominator I'm making as 20. Now I want you to observe both the circles. You can easily notice that 2 by 20 is little bit less than 3 by 30. Shaded part, observe the shaded part, right? You can observe over here 10 by 13 is more than 10 by 20, right? In 10 by 20, only the half circle was selected, and 10 by 13 is more than half circle is selected. From this, what can you conclude? Now here we are comparing the denominators. Since the denominators are not same, we are comparing the denominators. Okay. So when the denominators are different, we will compare the denominators like 5 and 6. Okay. In the stimulation that we have seen, it was 13 and 20. And you must have observed that in this, when the denominator is 13 in one case and in the other case it is 20, the 2 by 20 was less shaded because only the half circle was shaded, and 2 by 13 more than half circle was shaded. Yes, so here we were comparing the denominators. So comparing the denominators, we'll see which denominator is bigger or smaller. In the case 2 by 5 and 2 by 6, 5 and 6 if you compare, yes, 5 is smaller than 6. Perfect. Now, smaller the denominator, greater the fraction. Okay, like in the stimulation, we have seen that 2 by 13, the denominator 13 was smaller than 20, right? With the shaded part was more. So, smaller the denominator, greater the fraction. So, 2 by 5 will be greater than 3 by 5. Okay, we are comparing two fractions 2 by 5 and 3 by 6. Since 5 denominator 5 is less than 6, 2 by 5 fraction will be greater than 3 by 6. Okay, you can just see the simulation once again to understand. Here you can see that you see as I move the slider, you can see the denominators are same, the shaded part is same, right? 2 by 13 and 2 by 13. You can see that the shaded part is same. I'm just changing the numerator. Now I'm going to change the denominator. I'm making it 20 to 20. Now just observe both the circles carefully. 22 by 20, the denominator is big, the shaded part is less. Compared to 3 by 13, where the denominator is smaller, but the shaded part is more. Right? So smaller the denominator, greater the fraction. So when the denominators are different, we will see the denominators. Smaller the denominator, greater the fraction. You can easily observe over here. The smaller denominator has greater shaded part as compared to the greater denominator, right? So I'll repeat the steps. When the denominators are different, we'll compare the denominators. The denominator which is smaller, that fraction is going to be the greater fraction. Understood? Now let's quickly recall whatever we have done in this class. So what is the first thing that we have completed? We have seen what is a fraction. Yes, a fraction is a part of a whole. Then we have seen how to represent a fraction. So here you can see the picture. You tell me what is the fraction form of that? Yes, you can see a circle which is divided in four parts. Out of that, two parts are selected. So the fraction is going to be 2 by 4. Correct. Wonderful. Next, we have seen comparison. So in that comparison also, we have seen two things. First, when two first thing is when the denominators are same, comparison is easy. We will directly compare the numerators. Second, when denominator is different. When denominator is different, we will compare the denominators. Smaller the denominator, greater the fraction. Wonderful, great. So in the next class, we will be studying different types of fraction. In today's class, we have seen what is a fraction, how to represent a diagram in the form of fraction, comparing fraction with same denominator and different denominators. So now in the next class, we'll be seeing different fractions and operation on fractions like addition, subtraction, multiplication and division. Thank you for watching.